Oh, hey everybody, this is Mr. Dressel, and if you're still struggling with how to factor, I wanted to see if I could maybe help you out a little bit. And we'll start with one of the easier cases. Now, just because this is an easier case doesn't mean that this is necessarily easy. This can be a pretty difficult skill. But I think it is a lot easier to understand factoring if you're really comfortable with the concept that factoring is a way to undo distribution. Now, this is essentially an algebra class, and we are learning some very important algebra tools. And algebra is all about different ways to do and undo some sort of action. You learn how to add and then subtract. You learn how to multiply and then divide. Later, you learn how to square something, and then you learn how to square root something. With factoring, we first learn how to distribute, and then the factoring we are doing is how to undo distribution. So before I go over this as an example problem, I want to actually go straight to the end and think about how I would distribute to even get a trinomial like x squared plus 7x minus 60. So the answer to this is going to be, and we'll see how I get this answer in a little bit, but we're going to start by seeing how distributing gets to this question. This would be x plus 12 times x minus 5. Now, let's go through and actually distribute these two binomials. This is going to help us. And think about what we do. Think about how I would want to do these backwards. So there's a couple ways to distribute, but I'm going to be sticking with the area model. There is a way to both distribute and factor using, we call it FOIL or grouping, but I'm just going to focus on the area model because I really like it. So if I distribute, I need to multiply x times x times negative 5, 12 times x, and 12 times negative 5. That's going to give me 4 products, and a really clean and easy way to organize those 4 products is with one of these area boxes. You've seen these before. So when I multiply these, x squared, I get an x squared, I get a negative 5x, I get a 12x, and a negative 5 times 12 is negative 60. So then when I take this distribution, distributing means that I am multiplying everything against everything. And then when I write a final form, I have to make sure to combine the like terms that I always get. So these are all of my terms after I distribute, but I always have this last step where I combine the like terms. Now, the reason I want to go over this is because think about how if we flip this whole problem upside down and we start at the end, the thing that makes factoring harder than distributing is the fact that I can see this 7, there's number 7 in the middle. And the thing about that 7 is that it is actually 2 numbers. It's actually 12x minus 5x. And I don't know at first what 2 numbers were added together to make my 7x. So now when I go over back to our actual problem here, the thing that makes factoring difficult is I need to figure out a way to split up this 7 into whatever the 2 numbers that added to 7. I need to figure out what these 2 numbers are that ultimately combine to make this 7x. And that's the mystery. And this is where it becomes like a bit of a puzzle. How do I figure out what 2 numbers added to 7x? Well, going over here, it turns out for this case, the two numbers are 12 and -5. And the information I'm going to use is that I know that these numbers multiply to this last number. We call that the C. It's the constant. So when I am doing the work of factoring, I have to think of how could I split up the middle number into two numbers that multiply to the last number. Now, a typical way we do this is with this fancy X. I'll point out that you don't have to use an X like this, but this is a fairly common method. We write A times C on top, B on the bottom. The A times C, that has to do with when we do the harder problems. But I'm going to just fill in 1 times -60 goes up top. 7, that goes in the bottom. And now when I think about what two numbers multiply to -60, I'm thinking about numbers that also add to 7. So it really helps to think about the numbers that multiply on top because there's only so many that do that. There's a ton of numbers that would add to 7. But if I just take -60 and I think about possible pairs, well, I mean, I could do -2 and 30. I have to make one of these negative, but that would be 28. That wouldn't work. I could do, well, I could divide 60 by 5, so maybe I try maybe -5, and that would be 12. Oh, and then I see, yeah, +12, -5 multiplies to a negative number, and since 12 is bigger, they add to a positive number. Those are my two numbers. And the reason that this kind of problem is easier, if there is nothing in front of the x, I don't have to build a box or anything. I can just simply say x minus 5 and x plus 12. And that's all it is to it. I am just finding the numbers that added together to make that middle term. And I use the fact that I know that these numbers will multiply together when I distribute to make that last term. I hope this was a bit helpful.